Hi everyone. I wanted to make a video to reiterate the linearization process on LoggerPro that we talked about today in class. So here is a plot of the data that's included on your linearization of graphs handout. So you should be able to plot this data, no problem. Let's determine the line of best fit. Remember this class we talked about using the power function. So let's check that out. So we've got, that looks pretty good. We've got a coefficient of 19.05. The B value, or the power, is negative 0.96. You may have noticed when we talked about which powers we typically see in physics, they were whole number powers, negative whole number powers, or 0.5. So when we look at this, this is very close to -1, so let's just make that so. That changed our coefficient a little bit, so we can use these plus or minus buttons to adjust that. Okay, so we can play around with that a little bit, or something that we can do is we figured out using the power function that it was an inverse. Let's go ahead and just use inverse as our line of best fit. Cool, so 20.22 is our coefficient, and we'll say OK. All right, great, so I'll drag this out of the way. Now, when you've got your line of best fit and you've got your data scaled nice so that the highest point on your graph is just beyond your first data point and the right-hand side of your graph is just beyond your last data point, and you see 0, 0 on your graph, then your graph is good to go. And you want to either right click or two-finger click on your mouse, and you actually want to just copy. Okay, that will copy it as an image that you can then paste into your document. So you want this graph if this was the graph of your data in your lab. And then we want to linearize. So if we look at our line of best fit, we've got acceleration equals our constant 20.22 over m. So we could also write this as our constant, or a equals our constant times 1 over m, or our constant times mass to the -1 power as an inverse. So our equation is telling us to take our mass to the -1 power, and so that's what we should do. So you could do this by hand in a calculator, or you could have LoggerPro do it for you. So let's go up to data. We want to make a new calculated column. And this calculated column is going to be the values that we're using to linearize. So in this case, we either want to call it 1 over mass, right? Because that's what our equation is telling us to do, take the inverse of mass. Or you could call it mass to the -1 power. To do that, you could actually use Shift-6 as a caret to indicate a power and do -1 like that. Perfectly acceptable. But it's not quite as pretty as using these formatting options. So we click that little down arrow, superscript negative, superscript 1. Isn't that lovely? And then the short name will be the same short name that we use for mass, m, to the -1 power. Okay, and let's see if I can copy this. Copy. And then our units will be kilograms. Paste, yay, to the -1 power. All right, good. And this is all what will kind of show up on your axis label, and these units will show up in your best fit box when you've determined that. So our expression is where we want to tell LoggerPro how to do our calculations for us. And really we want to take all of those masses from a column and take them to the -1 power. So column, we want to take everything in column labeled mass and we want to take them to the -1 power. So in the expression section, we don't have the option for pretty formatting. We actually need to use the caret and -1 to indicate this. Or the same thing can be done by just doing 1 over the mass. This mass in quotes is the code for everything in the column labeled mass. So we're going to say done. Okay. And I already made a column that's called that. So I'm going to say cancel. So I had tried this previously, and we've got a column where all of that is done for us. So all of these are 1 over the masses that we had entered before. Okay. So now that we've taken a screenshot or we've copied our nice original line of best fit between our variables, we're going to X out of that. And then we want to go down to the x-axis label, because you notice nothing has really changed about our graph when we calculated those inverses. We still have to tell the graph that we want to have mass to the -1 power on our x-axis. Great, so there was a change when we selected that. And finally, we don't want all of our data on the far left. We want to 2-finger click or right click and select auto scale from 0. Our graphs, you always want to see the origin, and you always want to see all of our data and not much more. One of the things about auto scale is it smushes this very last data point up into the corner, and I want to fix that. So I'm going to hover over the axis, and I'm going to pull the axis over a little bit and down a little bit. There we go. That looks great. Then we want to go back into curve fit, and let's do linear. Okay, when we choose our line of best fit for our linearized graph, let's try fit, but we always want the slope to be the same as the constant from our previous graph, so 20.22. Right, and we always really want the y-intercept to be 0. Okay, so that looks pretty good. And we'll say OK. So remember, there are some things that you can do to make everyone's life a little easier. You can double click on this box, and you can change the number of sig figs or decimal places if that's appropriate for your data. You can also change the appearance. So you can make this bigger. I'm going to change this to 14, and you can make the color of the line and the text in the box different. Let's stay with black for our central line here. See, that looks much nicer, and you've got units even. All right, now let's make our maximum slope. So we can go back into curve fit, linear, try fit. Now here's the thing. We want to be able to adjust the slope of this line for our maximum slope. So we want it to connect at the top of our tippy top error bar and the bottom of our smallest error bar, and that's hard to do in this region because everything's so tiny. You can click on manual, but there's some problems with that, so I want to show you a workaround. I would actually just change the slope significantly, so let's do like 22. So you can see this line is distinctly different from the previous one. And I'm just going to say, okay, it doesn't matter what that value is. Okay, so there's that. I'm going to double click again. I'm going to change the appearance, make this one font size 14, and let's make the maximum slope like this bright blue. Okay, and then for some reason, I don't know why, by changing that slope in the best fit box manually, it allows you to click this enable line drag. Again, I don't know why. You won't be able to enable line drag by just choosing the manual option. You have to like actually fiddle with the slope before you press OK. So we're going to enable that line drag. Okay, so now we've got a nice big box that we can see. And we've got these little diamonds, and we can drag our line around. So I'm going to align this with the top of this error bar and the bottom of this error bar. When figuring out which points you want to use to define your max and min slope, you want to look at the 2 points near the ends of your data set. So you'll be choosing between this point and this point to define your max and min slope, and you'll also be choosing this between this point or this point. Right, you want to choose the one that's nearest to your line of best fit and on the ends of your data set. So I'm going to choose this point and this point because they're both pretty close to my line of best fit and they are on the very ends of my data set. All right, so if we look at this, that looks great. And so just to prevent myself from making an accidentally dragging my max line around, I'm going to double click and unenable line drag. Okay, and that locks that down. And you'll notice the slope was automatically calculated for us, which is really nice. Let's do it one more time. Try fit. Let's make it like 18 just to distinctly make it different. And I'm going to drag this box back here. I'll change the appearance. Let's make this one like a dark orange reddish color. Make it bigger so we can see it easily and enable line drag. All right. So now that's nice, and I'm going to drag this around and find my minimum slope. So whatever data point we use to define our maximum slope, we have to use to define the minimum slope. Okay, so I'm dragging that. So that goes on the very bottom of this error bar and the very top of this error bar. That looks pretty nice. Double click on this again, unenable line drag so nothing happens, and then we can align these nice and neatly. Sometimes I like to do, the colors are nice for associating one line with another, but sometimes I like to do this so that the boxes are really clearly showing our maximum slope is the highest, best fit, minimum slope. Okay, so now you've linearized, you have found the max and min slopes, and the last step is to find the uncertainty of our slope by taking the maximum minus the minimum slope divided by 2. And that's the process for linearizing a nonlinear graph to find the uncertainty of the constant.